if we have it written like this, so we can, this is how we can see it, the nth, and this is how this reads, the nth root of b, so b is the base, and we're trying to find the nth root, and if we write it as b to the 1 over n power, they really mean the same thing. So what it's really asking is, what number times itself n times is b? What number times itself n times will give me b? So like we just said with 16, what number times itself twice will give me 16? And we decided it was 4. So we can say that n is the index, also known as the root. So we call it, when there's a little number written in the crook of that radical sign there, by the way, that's a radical sign, and we use...
Samantha Drake to the junior high office, please.
We use the word square root only when the index is 2. When there's nothing there, it's an invisible 2. It's an understood 2 for n, and then we use the word square root. Otherwise, we need to think of that as a radical sign. So when they do actually put a number there, we call that the index, and it tells us which root of b we need to find. So let's go take a look at 8 to the 1/3 power. It's really asking for the third root of 8. So 8 to the 1/3 power is asking for the third root of 8. What number times itself 3 times gives you 8?
2.
Oh, and it's 2. 2 times 2 times 2 does equal 8. So we would say 8 to the 1/3 power equals 2. So our final answer is that 2. What times itself 3 times the index? What's the index in this one? Well, since it wasn't written that way, it was written as here's how it was written. It was written as the b to the 1 over n power, so the index is 3. The n is actually 3. So I want you right here, I want you to put that this is another way that this could be written. It could be written like this. If they show it that way, it means the same thing. N is 3, the index is 3. It's asking you for the third root of 8. It's asking you for what number times itself 3 times will get you to 8. So then 81 to the 1/4 power, what would be the index in that one? 4. It's really asking for the fourth root of 81. Fourth root of 81. Or in other words, what number times itself 4 times gives you 81? Here's what your brain needs to process. So now it can't be 2, right? Because if you keep multiplying by 2, that ends in an even number. So let's try the next number, maybe 3. What's 3 times 3? 9 times 3? 27. 27, now we got one more factor we need. 27 times 3. Well, 3 times 7 is 21, and then 3 times 20 is 60, and 20 plus 6, 21 plus 60 is 81. So the third root, 81 to the 1/4 power equals 3, because 3 times 3 times 3 times 3 does equal 81. And if you don't believe us, check it out on your calculator. 3 times 3 times 3 times 3, or in other words, 3 to the 4th power is 81. Any questions so far? Because again, you're really not supposed to be using your calculator to do this. You're processing through it, just like we're doing here. So in number 3, now they have the sum of two powers. The sum of two powers. So what we really have here is 121 to the 1/2 power is the same as the square root of 121. And 256 to the 1/4 power is really the same as the 4th root of 256, just like I wrote over here. Well, then now we're just going to process through that and say, okay, what does that mean? It means square root of 121 means what? We're looking for, don't give me the answer. We're looking for something times itself that equals 121. Anybody got that memorized yet? 11. Now we're looking for something times itself. We're looking for the 4th root of 256. We're looking for something times itself how many times? 4 times equals 256. Well, 2 might work because this is an even number at least, 256. Should we try 2?
No, we should try 4.
Oh, we think we should try 4. Could you give me some good reasoning right now why we shouldn't have even started at 2?
Because it doesn't even equal 6. And there would have to be an 8 at the end.
Would it have to be a what at the end?
Like, alright, so this is what I did. So I looked at the number, it says 256, right?
Yeah.
Looked at the last number and it's 6. Wow, what times 4? Like 4 times 4 is 6. 16. Whoops.
See, that maybe it just might work with that, huh? Yeah.
Uh-huh.
Well, and didn't we just find the 4th root of 81?
Mm-hmm. Yep.
And what was that? 3. And 81's less than 256, right? So if the 4th root of 81 is 3, and 81 is smaller than 256, it can't be something smaller than 3, can it? So let's jump up to 4 and try it. 4 times 4 is?
16.
16 times 4. 64. 64 times 4. Are you sure?
Yeah. Yes. Yeah.
4 times 64. 4 60s is?
This is working on my board.
4 60s is 240. 4 6s is?
Yes, I'm sure.
24. Or 4 4s, I mean, not 4 6s. 4 4s is 16, so it does work out. The 4th root of 256 is 4. So in other words, we're looking for what times, and I want this in your notes here. We were looking for what times itself is 121. We decided that was 11. We were looking for what times itself 4 times equals 256. And we decided that was 4. It's not 4 because we were looking for a 4th root. It was 4 because we're looking for the 4th root of 256. Okay? Because notice, if it was the square root of 121, why wasn't that 2 then? It's got to be what times itself. 4 times gives you 256. Well, then our final answer is 11 plus 4. What is it? 15. Back to easy math. 11 plus 4. Okay. Okay, number 4. 27 to the 1/3 power means we're looking for what? Which root? The 3rd root of 27. 1 to the 1/5 power means we're looking for the 5th root of 1. Which really means then, what times itself 3 times equals 27?
3.
That's 3 minus. What times itself 5 times gives you 1?
0.2. 1. Would it be 1?
Is 0.2 multiply times itself going to get you?
Oh, no. Sorry.
Added it will, but not multiplying. So I think Benjamin's right. I think it's 1.
Sorry.
In fact, I'm kind of convinced that no matter what root you're looking for of 1, it will be 1. Yeah, I'm kind of convinced of that. 3 take away 1 is? 2. Our final answer is 2. So, oh, we didn't, oh yeah, I just didn't fill it in. What's the 3rd root of 27? What times itself 3 times is 27? You should be starting to get some of these powers, like just, like they're just there. You're like, oh yeah, 3 to the 3rd power is 27, 3 to the 4th power is 81. You could go at least a ways. I know you can. I know your brains are capable of it. Any questions on this side? What kind of work do you suppose you'd show me until you have me convinced you and me convinced you really know what you're doing?
Probably all that.
Probably all that, yeah. Something that. Okay, let's go to the back. Well, not always is the numerator 1 like it was on the front side. Not always is the numerator 1. Every time on the front side, the numerator was 1. When the fraction exponent has a numerator that is a whole number greater than 1, then you better deal with this side of your notes. We can write it as a power to a power. We did that property yesterday in those simplifying powers notes that we did together. So when they have a base, b, being raised to the m over n power, where m is not 1, it's something greater than 1, we can rewrite it as b to the 1 over n power raised to the m power. Okay, stay with me on that. Why can we do that? Because when we have it, remember the power to a power property? What do you do with the exponents to simplify it? When you have a power to a power, remember yesterday in our notes we had b to the 3rd power being raised to the 4th power. What did we do? What was the shortcut? Multiply them, right? So if we took 1 over n times m, I could put that over 1, correct? Would that get me back to what it started as before I said we could break it apart? 1 times m, n times 1, n. Same thing, means the same thing. So now that we know we can do that, now what we're basically saying then is that we are looking for the nth root of a number, just like on the front. Whatever was downstairs in our denominator, that was the root we were looking for. So we're looking for the nth root of a number, and then we're going to raise that, whatever that root is, whatever we find it to be, we're going to raise that to the m power, or the numerator's power. We didn't have to do it on the front side, because when we raise something to the 1st power, it doesn't change it. So we didn't have to bother with it when the numerator was 1. But on this side, we will have to. Okay? So, number 5, 16 to the 3/4 power. They're not asking us what 3/4 of 16 is. Because that answer would be, anybody know what 3/4 of 16 is? 12, yeah. That answer would be 12, and I promise you the answer is not 12. Okay? So 16 to the 3/4 power can be rewritten. Remember what I said? The denominator is the root. We're looking for the 4th root of 16. So 16 to the 1/4 power. That answer is going to get raised to the 3rd power, the numerator. So what is the 4th root of 16? What times itself 4 times equals 16? 2. So we have 2. That's what 16 to the 1/4 power became. Now that 2, only reason I left the parentheses there is so you could see the 16 to the 1/4 got replaced with 2. And now we have to cube that 2. What's 2 to the 3rd power? 8. 16 to the 3/4 power is not 12, not 3/4 of 16. It's 8. I want you to take number 6 and I want you to see if you can write it like this right here. Just try that step. See if you can write it, breaking that fraction apart. What root are we looking for? And then what power do we have to take it to? Okay, who's going to offer up what they have on their paper for me? Tate, what is it?
25 and 1/2.
To the 1/2 power?
Yep.
Okay.
And then 3.
And that raised to the 3rd power. Good. That's exactly how we should break it apart. This is asking us for what? That 25 to the 1/2 power is asking us for what? You know what?
Number times itself.
Yeah, what times itself equals 25 because it's the square root, the second root. So what times itself is 25? 5. So now we can say, oh, well that got replaced with 5, and now we have to take 5 to the 3rd power. 5 times 5 is 25. Times 5 again, 125. 25 to the 3/2 power equals 125. I want you to note something there between those two. The first one was being taken to a fractional power less than 1. 3/4 is less than 1, correct? Okay. Notice something about the result. Is it larger or smaller than the base? Is 8 larger or smaller than the base 16? Smaller. The fraction was less than 1. Okay, what happened in this one? Our fraction is 3/2. Is that less than 1 or greater than 1? Greater than 1. And when our fraction was greater than 1, was the result, was it greater than the base or less than the base? Greater. So start, making that connection that when you get your answers, don't just be happy to have an answer, but try and make sense of it. If the fraction is between 0 and 1, you better get a result that's smaller than the base. When the fraction is greater than 1, you better get a result greater than the base. Okay, how would we write this next one? How would we start it out? 27 to what power? 1/3 power. Is anybody else catching on to this besides Tate? Yeah, you guys got this? Okay, 27 to the 1/3 power, and we're going to raise that to what power? 4th power. Don't make sure those exponents are small. Don't make it look like a multiplication problem here, folks. This is a power to a power now. And now we're going to say, okay, well, I am looking for what times itself 3 times equals 27. That's 3. Or in other words, the 3rd root of 27 is 3. And now I have to take that to the 4th power. Well, if 3 to the 3rd power is 27, 3 to the 4th would be one more factor of 3. 27 times 3 is 81. Did what we say should happen happen? Is the power that we start with 4/3 greater or less than 1? Greater. Should our result be greater or less than the base? Greater. 81 is greater than 27. Okay, 1 to the 4/5 power. Cameron, how would I rewrite that one? Well, at least I got your head up. You want to pass? Or you want to do it? 1/4 power? 1/5, yeah. And then that is going to be raised to the 4th power, yeah. I'm kind of predicting in this case it wouldn't matter, but we still need to know how to set it up correctly. Okay, so we're really looking for what times itself 5 times equals 1. 1. And 1 to the 4th power is 1. Think we're ready to say that no matter what power you take 1 to, you're going to get 1? I'm kind of thinking that's going to be 1 to any power, even the 0 power, wouldn't it be? Even the 0 power would be 1. How about a negative power? Could you try that in your calculator? Let's just check this out. Is 1 to the 0 power 1? Because I'm kind of convinced all the positive powers are going to work, but I want to make sure that any real number that we take 1 to will work. What's 1 to the 0 power? 1. Because anything to the 0 power except 0 is 1, right? Now, would you try a negative power? Would you take -1, raise it 2, and then parenthesis negative, and then, I don't know, let's take 6 for the fun of it. Parenthesis. What's that? 1. So no matter what how we take 1 to, we can shortcut this and say it's always going to be 1, isn't it? Okay, how about 0? 0 to the 5/6 power. That really means what? 0 to the what power? 1/6 power raised to the 5th power. So it's really asking what times itself 6 times gives you 0. 0. Oh, this is kind of sounding like the 1 guy. So now we have 0 being raised to the 5th power. And 0 times itself 5 times is 0. So how do you feel about this? Do you think 0 to any power will be 0? Any real number. Any number from the number line. Oh,
No.
wait a minute, Benton.
Not a negative number, because you get like 1/0, and that's not a number.
Let's try it on our calculators. Let's take 0 to the negative 6th power. I don't know why do you keep putting them away? 0 to the negative 6th power. Error. Are you sure? People who are saying error don't even have a calculator in front of them. Yeah, domain error, huh? And isn't there another number besides negative you can't do? 0. Remember, anything but 0 to the 0 power is 1. So if you try 0 to the 0 power on your calculator, it should also give you domain error. So the only thing we can take 0 to is what kind of a power? A positive power. As long as 0 is being taken to a positive power, we can say it'll be 0. 1's, it's happy to let you take it to any real number, anything from the number line, but not 0. Okay, what are we going to do with this number 10? 4 to the 2.5 power. Macy? Okay, so in other words, you're going to change that 2.5 to an improper fraction, huh? Is that what you're doing? So 4 to the what power then? Power to the, well, no, what's 2.5 as an improper fraction, first of all? Yeah, 4 to the 5/2 power. So let's start there. Let's rename it as an improper fraction exponent rather than a mixed number exponent. And then we can say, okay, now that can be renamed as 4 to the 1/2 power raised to the 5th power. 4 to the 1/2 power is asking us what? What number times itself twice is 4? 2. So now we have 2, and that's being raised to the 5th power. Well, 2 to the 4th, I remember a ways back in here somewhere was 16, wasn't it? So we got one more factor of 2. 16 times 2? 32. We end up with 32 as our result. And again, 2.5 is greater than 1, so our result should have ended up greater than 4. And it did. Okay, books open to page 399, please. And we are on the check it out problem at the bottom of the page, it says. And we're going to have to kind of refer to the example 3 biology application because that one gives us the equation that will help us find what we need. So let's just go up and read, first of all, up in example 3, the approximate number of calories, C, capital C, that an animal needs each day is given by the equation C equals, capital C for calories, equals 72 times m to the 3/4 power, where m is the mass or the weight of the animal in kilograms. So they did one for a 16 kilogram dog in that example. In the check it out problem, we're supposed to do one for an 81 kilogram panda. So let's first of all write down the equation that will help us do that. C equals 72 m to the, which power again? 3/4 power. Now notice, it isn't 72 m in parentheses being taken to the 3/4 power. It's 72 times m to the 3/4 power. So only the m is being taken to the 3/4 power. Well, first of all, we know that this bear weighs 81 kilograms. Is that the C or the M? M. So M equals in this problem 81. So we're going to substitute 81 in for our M. And if you have not discovered this yet, it's time for you to discover it. In order of operations, we do not multiply first and then do exponents. We do exponents first, and then we go back and multiply. So the next thing we're going to do here is we're going to take that 81 to the 3/4 power, and we're going to do what we just learned how to do. 81 to what power? 1/4 power. And then that's going to get raised to the 3rd power. Because of course we could just type this into our calculator and let it do it all, but you're going to show the steps of work to show me that you know how to process through this. That you're just as smart as your calculator. 72 is still 72. What is 81 to the 1/4 power? In other words, what times itself 4 times is 81? 3. We got that now, right? We know that 3 to the 4th power is 81. Now, so this is kind of like we were doing. The parentheses became 3. Well, now we got to back down and say if 3 to the 4th power was 81, what's 3 to the 3rd power? 27. So C equals 72 times 27. And of course, now I'll let you use your calculators this one time for actual calculation, not just exploration. 72 times 27. So capital C equals 1,944. And what are those? Calories. That panda bear is supposed to eat 1,944 calories per day at this weight. Okay, questions?